Hello, teacher.
Hi, Bruce. How are you?
I'm fine, thank you.
Good. How's your week so far?
Uh, I made a new toy gun today.
Oh, okay. Okay. Do you have it in front of you?
Uh, yes. It and it can make four bullets one time.
Oh, it can shoot four bullets at one time?
Yes,
Okay. Do you have it?
yes, I have it.
Okay, turn it around, turn it the other way. Uh, oh, turn it to the front, like to sideways, so I can see the top of it. Okay. Very good. How long did it take you to make that gun?
1 hour.
An hour? Okay. All right. Is that something you'd like to play with?
Yes, I like play it.
You like play with guns? Okay. All right. Are you able to play with your friends with stuff like that?
No, because I am still looking it. Will it be broken?
Oh, okay. Okay. All right. Well, good job. Good job. Hey, anything else going on? Anything coming up for you this weekend?
And we have English test yesterday.
Oh, you had an English test yesterday.
Yes, we had an English test yesterday.
How do you feel about it? How did you do?
100.
Oh, excellent. Good job. All right. Good for you. All right. Anything coming up this weekend for you?
Not yet.
Not yet. Okay. All right. Okay. Well, very good. Well, let's take a look in at your homework, right? I told you I asked you to do a Venn diagram, and you did. So good job. You want to explain that to me?
Yes. Volcanoes. Magma burn everything. Landslides, dirt, sand, rock slip from mountain.
Okay. And what is the common ground?
They are both disasters.
Disasters. Okay. Good job. And then let's take a look at what do we have here?
Tornado.
Oh,
The wind on the top, 12 kilometers to 18 kilometers. Move direction. The
okay.
wind in the middle, 3 kilometers to 6 kilometers. The wind on the floor, 10 meters to 600 meters.
Okay. All right. Good job. And I like the way you have that wind going up into the funnel cloud, or how it's forming that funnel cloud. Okay. Good job. Did you like doing that?
Yes, I do.
Did you? Okay. Good. Good. All right. All right. Let's take a look. I think we're back up here. This is kind of where we left off the week before your holiday, and we were still talking about tsunamis, and I think we kind of stopped here. So we'll talk about the next part they're talking about is that there was a big earthquake in 2011, which was about 10 years ago. So we'll go ahead. I'll have you go ahead and start there. Okay.
Okay. The 2011 Japan earthquake produced two tsunami waves more than 30 feet, 10 meters high. The 2004 Indian Ocean earthquake is in southern ESA produced 50 foot, 15-meter tsunamis.
Tsunamis. Remember, the T is silent. You pronounce the S, but you don't pronounce the T. So it's tsunami.
Tsunamis.
Yeah.
These tsunamis engulfed entire cities and shorelines. The wave swept away buildings, cars, and people. Japan, South Asia, and
Chile.
Chile had experienced many powerful earthquakes and tsunamis before. Why were so many people unprepared?
Okay. And now let's talk about predicting earthquakes.
Predicting earthquakes. Seismologists are very good at measuring earthquakes. However, they still can't predict when earthquakes will happen. There was a time, Dr.
Cifuentes.
Cifuentes explains, when I think science felt that predicting earthquakes was just around the corner, that were going to be able to predict earthquakes very soon. But it's clear now that it's not around the corner. In fact, some have given up entirely on predicting earthquakes. One reason that earthquakes are unpredictable is that science cannot collect enough information to understand when, where, and when an earthquake might happen next. Although scientists have placed special instruments in many earthquake zones, earthquakes still surprise us. Scientists, for example, had believed the next big earthquake in Japan would happen farther to the south, closer to Tokyo. Instead, it stunk farther north.
It struck, yeah. Okay, and here's kind of a picture. Let's go ahead and read that sidebar. You see that.
A powerful tsunami forced people to flee to the roof of a control tower in a flooded airport.
Okay, so this is actually this building or this tall structure here is a control tower that they have at the airports. You know, when planes come in and out, and those are usually very high, so they can see everything. And as you can see, you have all these people on top of this building here just because of all the water that came in from a tsunami, right? Which comes in from the ocean. Okay, let's take a look at planning for earthquakes.
Planning for earthquakes. Even though we can't predict earthquakes, we can prepare for them. Many seismologists help make information available to people so they can plan for and respond to earthquakes. This is especially important near coastal areas. Once the shaking goes on for more than 30 seconds, Dr. Cifuentes says, it's pretty simple. You have to run away from the ocean and run uphill. You have maybe 15 or 20 minutes to reach higher ground. How cities are built also affects how many people survive an earthquake. Cities in many countries have special building laws. Buildings must be strong and flexible.
Flexible, good.
That's why they won't collapse during an
collapse
during an earthquake. In some countries, however, buildings are often poorly built. The 2010 Haiti earthquake, for example, killed between 64,000
40, that's, hold on, the number's transposed, 46,000.
46,000 and
How do you read that number?
316,000
Good. Good.
people. Unlike the earthquake in Japan, many of these people were killed by collapsing buildings and falling debris.
And just hold on a second. And just so we kind of understand all of that, do you understand why they say, or why Dr. Cifuentes here was saying, if you live near a coastal area, so we know that's like near the beach, right? So you have the ocean and you have the shoreline, okay? So let's pretend all of this is all water, okay? This is all water. And this, of course, is the shoreline, right? The beach. And then you have, you know, your buildings and stuff like that all over here. But if you have an earthquake, and he's saying if it lasts more than, 30 seconds, or even a minute or so, and, all the earth is shaking, everything's shaking, and then finally when it stops, you have about 15 or 20 minutes, sometimes even shorter than that, to get as high and far away from that water to higher ground. You have to move all the way to the top of where, the highest point is in that city, because that earth was shifting, the earthquake, everything. When everything goes back, that even means the water is moving, right? So all of this water is going to be very strong, and it's going to cause a huge tsunami, and the water is going to hit the land, everything up here, and then finally it's going to go back again, back into the ocean. But can you imagine all that water, if people were all in this area, when all that water finally comes up, it would destroy and kill many people, because that water is very heavy and it's very powerful. And so if you're living, or you're, in this area, and that water comes up, you're going to be, probably you're going to drown, because the water is too forceful, right? So you have to try to get as far away from the shoreline as possible. Does that kind of make sense?
Yes, that makes sense.
It does. And what is this word, collapse? What does that mean? Collapse.
They won't be destroyed.
Okay, give me another word though for collapse. What's another word we can say instead of collapse? Just the word collapse. Okay, you have a building. Okay, my hand is my building. You have a building, and if it collapses, what does it do?
It's falling down.
Yeah, exactly. Right. And like if you came home after playing basketball or soccer or something, and you were really, really tired, and you came into the house and you said, "Oh, Mom, I'm so tired. I'm going to collapse right here." And you just fall down onto your bed. That's the same thing. I'm going to collapse. I'm going to fall down, right? Usually, you can use it that way, but usually at the building collapse, of course, like you said, it will be destroyed. That will be the result of collapse, but collapse is to fall down. Yeah. Okay. And then read that last paragraph then.
Utility.
No. However, earthquakes.
However, earthquakes don't just destroy, they also create. They help make the mountains, coasts, and other landscapes we see around us. Dr.
Cifuentes.
Cifuentes explained, this is worth remembering as we learn how to predict and survive earthquakes in the future.
Okay, and then go ahead and read that sidebar there.
Utility ducts.
Utility ducts.
Utility ducts like this one are being constructed to protect underground wires, cables, and pipes in the event of an earthquake.
Okay, so that's like what they're building like underground, so it would be protected in the event there are, earthquakes and whatnot, so everything wouldn't have to be reconstructed again. And that looks like it's made like through a lot of cement and steel. If you look at this duct here, it looks like a lot of cement, which is very, very strong. Okay, so here's some pointers, what to do during an earthquake. Okay, go ahead and read all the ones first if you are indoors.
If you are indoors, drop to the ground and crawl under sturdy pieces of furniture until the shaking stops. Stay away from glass, windows, outside doors and walls, and anything that could fall, such as a hanging light or fan. Stay in bed if you are there when the earthquake strikes. Protect your head with a pillow. Only move from the bed if there is a heavy light fan above you. Use a doorway for shelter only if you know it is strongly supported. Stay inside until the shaking stops and it is safe to go outside. Do not use the elevators.
Okay, and that's kind of like a really important one, especially same thing with a fire, right? Why don't we use elevators in situations like that?
Because if you use elevators, the power will gone in anywhere, and you will just in the elevators and you can't come out.
Okay, so you'll be stuck, right? You'll be stuck in the elevator.
Yes.
Yeah. And that is the electricity might go out, right? So there won't be any power. So that means the door couldn't open or close. So, okay. All right. Good job. And once again, not just earthquake, but also fire. That's why we use the stairs. We can hopefully get out that way. Okay. And then if you are outdoors,
move away from buildings, street lights, and utility wires.
Mhm.
Avoid any space where there is falling debris, such as glass. Once in the open, stay there until the shaking stops.
Okay. And go ahead and read where it says, reread.
How can you protect yourself if you are indoors during an earthquake?
Okay.
Reread to check your understanding.
Okay, and I don't want you to read all through those again, but just from what you remember, just tell me a couple that you would do if you were indoors to protect yourself.
Stay away from the lights or fans.
Okay. Okay.
And protect your head.
Okay, that's a good one. And how would you protect your head? What would you do?
Use soft things to cover your head.
Okay, okay, like pillows and blankets and things like that. Yeah.
The teacher and can you protect yourself when the earthquake? You stay in the bathroom.
Yeah, I mean, some people say to go like into the bathtub, if you have a bathtub, because that, once again, usually a bathtub is made of a really strong type of material that can protect you from things that are flying around. But if your bathtub has like a glass door, because a lot of showers have glass doors and things like that, I don't think that's the safest, because if that glass breaks and you're in the bathtub, that could come falling down and cut you really badly. So if your bathtub doesn't have glass around it, then it's probably one of a good place to be. But if your bathtub has glass attached to it, like a glass door or something like that, that probably wouldn't be the best choice. Lots of times they say to get in, like this one was saying, to get into like a doorway. And the reason being is because where the door is framed, like with the door, there's more beams and heavier construction. So if you're right underneath, like if this is the heavy beam, the frame of the door where the joists are, if you're underneath that, that's a little bit more stronger and heavier to protect you. But yeah, I think many times it's, a lot of people though during earthquakes, same thing with, fires and things like that. They panic and they, try to run around and find, something. But I think the best is if you're really high, high up, and you have an earthquake, the best thing to do is just try to find the safest place in your house or say in your apartment until the shaking stops. And then when the shaking stops, it's probably best to try to go down the stairs, because many times there's always another, like an afterquake, like another one. And if people are most people will try to evacuate and just go down the stairs. And yeah, go ahead.
If you have an umbrella, can you raise it up and jump off your home?
No, no. If you have an umbrella and you want to jump off the balcony with an umbrella or something like that,
Yes.
No. That's you might see that in cartoons or something like that, but that will never work. Okay, there's way too much force. You will kill yourself if you try to jump off buildings with an umbrella. That will not protect you. All the wind will take that umbrella and turn it the other way, and you're just going to go down faster. So no, that won't work. The only time that would work is if not an umbrella, but like a parachute, maybe. Like a parachute that people use to jump out of planes. And if you were really high up, I don't know, but I would just say no, that jumping out with an umbrella, no.
Okay.
Will not work. Don't ever try that anywhere. Okay. Okay, and then if you're outdoors, honestly, with the earthquake, and I've been through a few earthquakes here where I live in Ecuador, because we get them from time to time. And, to me, it's just safe really being indoors. And I'm not that high up. I'm only on the 3rd floor. But you do want to stay away from objects in your home. Like I had a chandelier, lights, in my dining room area. And that when the earthquake happened, there was a lot of shaking of those lights, everything shaking. the cabinets are moving, you know, the walls are moving, the whole apartment's shifting. But you don't want to be like, if these are the lights, you don't want to be underneath those. You want to, because if that were to fall down, you know, that could really hurt you. So you want to be away from lights or any kind of ceiling fans, things like that. Because if it came falling down, you don't want it to hit you. So you just stay away from that. I think I just moved into like an open area. But yeah, they're interesting. They're really interesting, but they can be very dangerous. And in fact, the place where I live in Ecuador, just 3 hours from me on the coast, yeah, which is called Guayaquil, there was a lot of deaths because just like what you read about, where the buildings weren't made very well, a lot of those buildings came down during the earthquake, and a lot of people were killed in their homes because the buildings collapsed, and all that cement, that heavy cement, just collapsed and fell down on people and stuff. So that can happen too. But yeah, so it can be very dangerous. Very dangerous. Okay, so if you're outdoors, go ahead and read that one.
Move away from buildings or street light, and avoid
utility wires.
And utility wires.
Yeah.
Avoid any space where there is falling debris, such as glass. Once in the open, stay there until the shaking stops.
Okay. All right. So we know what we do indoors, and you also, you read that with outdoors. Here's another here's a picture, and these are kids that are obviously in school. You know, they're kind of going under their desk during that time. And, you know, I think that's probably as safe as place as any, because they're, you know, if anything starts falling, or, you know, maybe they're protected being under their desk. Okay. All right, and then let's go ahead and read about the author.
By the author, Snead be colored.
The third
believes that people can find signs anywhere they look. His mother and father were both biologists, so Snead grew up with exposure to science every day. He has written more than 40 science books for kids, many of them inspired by his own life and interests, including his frisbee catching dog. Today, he lives in Montana and enjoys writing about the American West and its natural beauty.
Okay. And the author's purpose, go ahead and read that.
The author's purpose. Snead B. Collard III uses interviews with scientists to inform readers. How did reading about Dr.
Inez Cifuentes, that's first name. Inez
Cifuentes' work help you better understand earthquakes?
Okay. If you want that question there, just go ahead and answer that one for homework. That way you can write about it a little bit.
Okay.
So on page 58 there, on author's purpose, just go ahead and answer that one.
Okay.
And then on the next page where it says summarize what you learned about earthquakes, well, you're going to kind of use it. You're going to answer that question here, so I'm not going to have you summarize that. You don't have to do that at all. Okay. But what I would like you to do is go ahead. This is the last part of your homework. Will be to answer those 4 questions. Okay.
Okay.
On page 59. But you don't have to do another Venn diagram. You don't have to do that because you'll answer the question in author's purpose. Okay, so just 1, 2, 3, and 4.
Okay.
Okay, and then we'll answer these questions in class. So on where it says make connections, go ahead and read that first one.
How can science help people prepare for earthquakes?
So what do you think?
I think they can in the ancient China people built a machine that can know where is earthquake.
Okay. Okay. And how about number 2?
Why should people take warnings about tsunamis seriously? Because it will hurt people.
Okay. And what causes a tsunami?
Earthquake.
An earthquake, right? Okay. Very good. All right. Let's take a look at the next one. And this one is tornado. Tornado. Find out what to do in the event of a tornado. Okay. Go ahead and read this one.
Tornado. When warm and cold air masses collide.
What does that mean? Hold on. There's that word collide. What does that mean?
Together.
So what was that?
Together.
Be more specific. Together would be something like this. I have a pencil and another pencil, and I have them right next to each other. I have 2 pencils together. Does that mean the same thing as collide?
No.
Okay. Give me a better explanation for collide.
It means 2 things come like
Show me. Give me an example.
okay, let me see. Like 2 magnets, you put them in the same direction, and they will collide.
Collide.
And collide and not cannot make them together.
You can't make them together. It's more of like a I know what you're trying to say, but let's just really put it in context what it is. It's like it's an impact. Okay, so if I had these 2 pencils and they're walking to each other, and all of a sudden, boom, boom, they collided, right? So it's impact. Like if something falls down, like a comet or something comes down from the sky and it collides, into Earth, it falls into Earth, hits the ground. Usually like a car hits a tree or a car hits a telephone pole, it collides, it crashes into something. Yeah. That's where they're kind of talking about that coming together when the warm and cold warm and cold air masses come together, they collide, right? Okay, go ahead.
The result can be a fast-moving, dangerous force of nature, a tornado. A tornado is a violent windstorm over land, which makes a rotating, funnel-snapped cloud that extends toward the ground. As it moves, it picks off debris and objects in its path. Tornadoes are a natural process, especially in flat areas, such as the middle of United States. But tornadoes can also be unpredictable.
Unpredictable.
Unpredictable. They may cause destruction on one side of a street, yet leave the other side untouched. One way you can tell the tornado is coming is if you spot a funnel cloud. Other warning signs include sound. An approaching tornado may sound like the rumble of a fast-moving train. It may also sound like a waterfall or like wind whipping into the open windows of a speeding car. Even after a tornado has passed, there are many hazards. Avoid stepping on glass, sharp objects, or especially falling power lines. Stay out of heavily damaged buildings that may collapse. It is important to treat a tornado as a serious crisis, as warnings may come quickly with little time to act.
Okay, and that's true with, I think, out of all of the natural disasters, I think the tornado is the one that is the one that people are least likely to prepare for, because they happen so quick when that air, formulates. You kind of get an idea, and I don't think in China, I don't think they have tornadoes there. From what I understand, I don't think so. But they're really common in the Midwest in the United States. So if you have, my drawing is awful, but let's pretend that this is the United States. I'll kind of just draw it how it kind of makes sense to me. Okay, so if that's the United States, you got, of course, you got California and you have Florida, but the Midwest is this whole section right here, like right in the center. And it's really flat there. There's no, obviously there's no ocean or anything around that. We have all the coast is all around this way, right? The coast is on the outside of the United States. But so there's no water here, but it's just flat. And that's where tornadoes usually formulate, in flat areas. And it's the mixture of, like they were talking about with that warm and cool weather, warm air and cool air, and it mixes together and it forms this huge funnel cloud. Hey, did I show you, I'm not sure last class, but did I show you on the internet like pictures of tornadoes? Did you see those? Did I show you them? Do you remember? No, I know I showed you some other. I think these are important when we talk about like different real live events, like like tsunamis, hurricanes, things like that, so you can actually see. There's actually some really. I'm going to just show you briefly, just so you can get a real view of tornadoes. Okay, because I think it kind of makes sense when. Oops. Hold on. you get a really clear idea. And these are real. So these are all real life pictures. And I think and they're very, to me, they look really wicked, really serious, really bad. And we'll kind of take a look at, here's a kind of a good one. Can you see any of these pictures?
Yes.
Yeah. So this is really what and usually it's always accompanied with rain and, it could be thunderstorms and lightning and things like that. But this is, as you can see, extremely powerful. You look at that, and it does. That's a funnel. It looks like a funnel. So when you see this forming, I've seen funnel clouds in Virginia, but I've never been in a tornado. And I've seen these forming in the water. And when they approach land, they're highly destructive. Yeah, so they all kind of look like this. They all come down with that that funnel type shape, and when that finally hits the ground, it just does massive destruction. I'm looking at this. I'm looking at this one here. As you can see, look at all these buildings here, and you see this funnel cloud. Once that hits the ground, it starts moving on the ground. This wind. All that is like wind. This wind is so powerful and strong, if it comes and touches that building, it's going to totally destroy it. And as you can see, these are the pictures of after a tornado's been through there. I don't know if it's going to take me to see these pictures. That it totally takes down trees, it destroys all the houses. It can lift animals, people in the air. I mean, it's just, because the winds are so strong. This is another one. This is just, to me, it's so bad. They look to me, they're really scary looking. And you would never want to be in the path of those tornadoes. And as you can see, when we're talking about like Midwest flat lands, you look at these tornadoes, it's all flat. There's no mountains, there's no water. It's all flat land. And that's where they normally touch down. Okay. Any questions on those?
No, thank you, teacher.
Okay. You find those interesting? For yourself, I'm just saying, do you find studying or looking at natural disasters like tornadoes, hurricanes, earthquakes, things like that, do you find those interesting in science, about science? Or not really?
Yes, the knowledge in them are interesting.
Okay, so it's interesting of how it all formulates, how it comes together. Yeah.
Yes.
Okay. All right, let's go to the next page here. Just kind of show you some examples of a tornado. Go ahead.
After a tornado hits, it is rated on a scale from 1 to 5. This scale rates the tornado on its wind speed and the damage it has done. Tornado safety. When you hear or see a tornado warning on the internet, radio, or television, take shelter right away. If you are in a building with a basement, move to the basement quickly. Get underneath a sturdy, large object, such as a workbench or table. If you are in a building with no basement, move to the lowest floor. Find the center room away from windows. Crouch down to the floor. Cover your head with your hand. Avoid being in a car during a tornado. If a tornado approaching, move inside a building if possible.
Okay. And one thing is, which is actually really safe during a tornado for the most part, if there is a basement, something underground, because if you go underground, and a lot of homes in the Midwest in the United States, most of them have basements. And what that kind of looks like, just if you're curious, it's the basements, like if this is a house, here's my my drawing of a house. Okay, so this is a house. Basements are made on the side of a house many times, a cellar or a basement they might call it, and it's dug underneath the ground, and it has like a door or something that opens that goes down. So if you have a basement, you go into the basement, and when the tornado is coming, it goes over this, right? It's not going to get underneath there. This is all going to be protected. So it might go over that when the funnel cloud is coming through, and it might tear down your entire house. But if you're in the basement, once that tornado passes, and if you were to come out, you would be alive, right? Your house might be destroyed, but you would be protected because these basements are dug underground. And why these are so scary is you don't really have a lot of time to prepare. An earthquake, obviously, because you feel the shaking, right? But with the tornado, many times they can just appear, and you might have maybe 10 minutes or something to get out of the way or something, or take kind of, precautions. People that have animals and I don't know, big machinery and things like that, they want to try to move those out of the way or something. Okay, let's continue. Go ahead and read that question. This is make connections.
What should people do in the event of a tornado?
Okay. So from what you read, what you remember, what should people do?
People go to the basement.
Okay. And what if you don't have a basement?
And go to the one floor.
Okay, try to stay on the first floor, right? So if you're up on another building, try to get down to the main floor. Yeah. Okay. And then how about question number 2?
How are tornadoes similar to other natural disasters?
Okay.
All of them are harmful.
Okay. All of them can be harmful, right? And not just to people, but also to property, right? Okay, good. And then the next one here we talk about is it's kind of like a cartoon. Go ahead and read that question.
How can science help you find out how things work?
Okay.
Read how forces and motion affect our lives.
Okay, this is what we're actually talking about with science, force and motion. Okay, go ahead and read that first page. This is Max Axiom, super scientist.
About Max. Real name, Maxwell J. Axiom. Hometown, Seattle, Washington. Height. Teacher, how do you read that?
That is 6'1". So he's 6 feet. I know everybody else in the world uses metrics, but we use this standard measuring. This is 6 feet 1 inch, but we just say 6'1".
Okay. 6'1", white, 192.
LBS stands for pounds.
Pounds.
Yeah, I know you guys use kilograms, things like that, but we use pounds. Okay.
Eyes, brown, hair, none. Capabilities. Super intelligence, able to shrink to the size of an atom. Sunglasses give X-ray vision. Lab coat allows for travel through time and space.
Okay.
Origin. Science birth. Max Axiom seemed destined
Destined.
for greatness. His mother, a marine biologist, taught her son about the mysteries of the sea. His father, a nuclear physicist,
Physicist.
and
Yeah.
volunteer park ranger, schooled Max on the wonders of earth and sky. One day on a wilderness hike, major charge,
Mega charge.
the maker charge, lightning bolts struck Max with blinding fury. When he awoke, Max discovers a newfound energy and sets out to learn as much about science as possible. He traveled the globe, earning degrees in every aspect of the field. Upon his return, he was ready to share his knowledge and new identity with the world. He had become Max Axiom Super Science.
Okay. And this is kind of, we'll see kind of like cartoon drawings, but he's going to explain a lot of different things, talking about motion, forces. Okay. So forces that move us. Go ahead.
Super Science Max Axiom jumps right into the world of forces and motion at an amusement park.
Okay.
What a perfect day. Even though everything feels turned upside down.
Okay. And what is Max doing here?
He is bunky.
But bungee jumping?
Yes.
Yeah, that's what it looks like. Okay. Go ahead.
Spinning, flying, jumping, and falling are just some of the amazing ways to move. But there's a lot of science behind the zoom around us.
Okay.
In fact, the world is full of kinds of motion. Everything that moves needs a force to get it moving. Back for another jump already, you bet. A force is any push or pull on an object. Bungee jumping depends on a force called gravity. Gravity. It pulls objects toward each other, and it keeps us on the earth.
Okay. Keep going.
Gravity is the reason I fall down, not up or sideways.
Okay, so we have gravity on Earth. We know this, right?
Yes. Okay. Wheel. Moving can be soaring, but I need a break. Hi, Rosetta. What are you doing here? What are you doing here? Hello, Max. I'm taking notes for physics class I teach. Why are you just sitting there? Is something wrong? Once I sit, sometimes it's hard to get moving again, but once I get going, I often can't stop.
Okay.
That's
inertia.
That's inertia for you. An object at rest tends to stay at rest. An object in motion stays in motion. That's Newton's first law of motion. It still object needs a force to get it moving. Likewise, a moving object needs a force to change its direction, slow it down, or make it stop. For instance,
Inertia.
inertia keeps that stroller rolling.
Okay, so you see the kids, yeah, they're having fun. Okay.
Until another force comes along to stop it. Oh.
Okay, and what was the force that stopped it? That stroller in this picture here, you see it moving. Well, it appears to be moving through the drawing, right? And the kids are having fun and they're going, wee, right? They're liking it. But in this picture, what's making the stroller stop?
Their father poet.
Yes. So we're taking the stroller's going one way. That's inertia. It's moving because it's moving. And the only way that stroller is going to stop is by having another force or a pull or a push or something in another direction. So you see in that picture, you see that father grabbing onto the stroller, the bar, and he's pulling it the opposite way from the way it was traveling. And that is the pull effect to make, and that's a force that he's doing, right? He's using a lot of energy to stop that from rolling. And this is we talk about Isaac Newton, and that's what he was saying here. That's Newton's first law of motion. He was a famous physicist, right? Study of physics. And this is when he lived, between 1643 and 1727. And go ahead and read who Isaac Newton was. Go ahead and read that.
Was the first person to realize that certain laws of nature.
Certain laws.
Certain laws of nature explain all motion on Earth and in space. He also was the first to explain the idea of gravity.
Gravity, okay. And then go ahead and read where it says reread.
Why does a moving object need a force in order to change direction, slow down, or stop?
Okay.
Read to check your understanding.
Okay, so why does a moving object need force to change direction?
Because that's an inertia.
Inertia, right?
Inertia. An
Okay.
object at rest tends to stay at rest. An object in motion stays in motion.
Good. Okay, and we need some kind of force to make it stop, right? And that could be a push, a pull, or something. Okay, we'll stop here. Any last minute questions?
No, thank you, teacher.
Before we go? Okay, so I know we'll be in the other book next week, but we'll come back here in 2 weeks to finish this one, okay?
Okay.
It's on page 67. Okay. Okay, so with that, you know your homework from earlier, right? Yeah?
Yes.
Okay. With that, hey, have a great week and have a nice weekend. Do something fun, and I will see you next week. Okay?
Okay.
All right. Bye, Bruce.
Bye, teacher.